have a couple of slides, just introductory slides. Ben Miller's with Dragos, who's a cybersecurity firm that you probably saw here in our technology exhibit. I don't know if you want the podium or
I'll just
sit down. Okay, no problem. Yeah, I'll take a seat here while you do that.
Trisis, also known as Triton, also known as Hatman. I think why we're talking about it today. So in 2009, we talked about Stuxnet. In 2010, we talked about Stuxnet. In 2011, we talked about Stuxnet. In 2012, we talked about Stuxnet. In 2013, we talked about Stuxnet. In 2014, things changed. So we started talking about Havocs. We started talking about Black Energy. And that continued on. And then we started talking about Crash Override later last year. And now we're talking about Trisis. Trisis is really just the continued evolution of malware that's affecting critical infrastructure, in this case, safety systems. And it's kind of fun in that, depending on how you define fun, in that Trisis is the potentially caught in the action of actually developing Trisis. And so we're actually seeing the evolution of the state of the art for malware that's affecting safety instrumentation systems. I am lucky in that I get to hang out in Slack channels where our reverse engineers are constantly reversing, in this case, Triconix firmware and the Triton malware. So they're talking about memory addresses and all these arcane things. And I have to reinterpret that into a slide that is meaningful. So that's my attempt on this slide. There are, ultimately, Trisis is a rootkit. We had long discussions on what exactly is Trisis. Is it a remote access Trojan? Schneider says it's remote access Trojan, but it's also doing some hooking and some other things. But ultimately, the language that we use, because actually all these things have various definitions, is a memory resident rootkit that is sitting on the controller itself, the Triconix controller. That gets delivered through a set of binaries that are sitting on the workstation. So this is trilog.exe and library.zip. You'll see in the trilog.exe when you reverse that, you pull out the actual code associated with it, the byte code. It references itself not as trilog.exe, but as script test.pyc, pyc being Python code. This was actually assigned by the developer. So you see script test and a lot of the functions and what it's doing does suggest that it is in active development by these authors, and then they're actively testing it. Which is interesting in itself, that we kind of call real-world testing of Trisis. But ultimately, a Trilog and its associated libraries, library.zip, communicate over the Tri-Station protocol to interrogate and upload new programs to the Triconix controller. The end result of that is that you have rootkit functionality. So when Trilog, or when Trisis finishes, it installs a memory that can, or it installs a program that's no longer acknowledged by the controller. So it's in stealth mode, that can arbitrarily read, write, and execute a memory on the controller, and that's dormant on that box going forwards at that point. And it won't show up in the program list if you are to access that from the engineering workstation. So basically, you have persistent access to the controller by the adversary in a stealth fashion, and that's what they were testing. Ultimately, is what it comes down to. So, talking about the ICS Kill Chain, is everyone notionally familiar with the ICS Kill Chain? The ICS Kill Chain is the idea of if you want to have a specific effect on an ICS, how would you go about doing that? And there are certain phases that you go through. Traditionally, these phases are in going through the IT network, not necessarily your IT network, but a IT network into your industrial control environment, And then from there, they're doing the development, the testing, the delivering, the installing, the execution of the ICS attack. What's interesting with this model from a defender standpoint is that if you disrupt any one of those phases, the attack's done. The attacker has to start over from scratch and continue on. So that's the value from a defender perspective, is that the earlier on you stop the attack, the better off you are, and the more cost is associated to the adversary on doing another attack and continuing that on. TriSys itself represents the last 3 or 4 stages of the ICS kill chain. That means there was ample time before that to actually discover, stop that attack. And that's some of the advantages of the amount of sophistication that you do need in order to not take down an ICS, because it's not that hard, but to gain access and to have a specific result and not get detected in the length of time that you need is still what is, quite frankly, state-of-the-art as far as any attack, whether on the industrial side or on the IT side. So I want to give that background of what TriSys is in the realm of basically state-of-the-art for malware on not just safety systems, but industrial systems in general. And then flip it over to you.
Thanks, man.
Yep.